Hi guys, today we are trying to create an example session related to what the pointer structure on the C++ or the C programming language. C++ covers the full picture of the C programming language, and so if you are trying to create a code in C++ programming, you can use the same structure with the C programming language. Okay. As always do, we need to create a project, the empty project for a C++ programming, and so today week 13 in here, and so specific location is given by the this notation in my computer, and so the browse section is set to week 13. And so create the project gives us the editor section on the Visual Studio Code. Okay, and so firstly we should create the source file in here like this one. The C++ should be selected, and so main.c with the extension of the C programming language is given in here. Okay, and so this session is directly related to what the example session, examples or example session. Okay, and so the first example is given by to what to pointer usage include stdio.h, and so in its main function in here return is 0. Okay, I'm sorry. Okay, and so firstly we are trying to what the random number generation by using what to rand function, as we previously discussed about it, and so we will utilize this functionality on our programs. Okay, and so in order to store the pointer address, and so we can use the int star with the name of the p value or the ptr value. Okay, and so if we have a like function, the get or the generate random number in here with the return value of the what, with the return value of the pointer address in here like this one, ptr. Okay, and so if we are using this function body and so the return value is equal to the what, int star value, and so the generate random number can be given by using these things. Okay, and so how can we create random numbers? In order to do that, we should create the static int r what, for example 10 variable in here or a variable in here, and so in order to create a loop variable, int I should be given at this position. And so firstly you should remember that the srand function or the seed random function should be initialized with what, the unsigned cast with the time null characteristics. And so if we are using the time, and so we need to add the std time.h, and so if we are using the rand function, std library.h should be added to this position, and so this assigns to what, the setting for seed values. Okay, and so how can we initialize these values on this position? And so we can create the for loops in here, I10, and so I++ should be added in here, and so AI should be assigned to what, the random values in here. Okay, because if we are using this notation, and so the a value should be returned to the ptr, and so ptr can be generalized by using these things. Okay. And so in order to return the a value, we should add the return a comments on this position. And so it's important to note that the static variable should be used at this position, because if we are not using static keywords in here, and so a is dismissed or a is removed by the end of the function of this generate random number, and so we cannot return to anything to the ptr value because the a is destroyed on the ram point, and so we don't have nothing. we have nothing at the end of these codes. Okay. And so if we are run these codes and then there is no syntax error in here, and so how can we utilize to what, or how can we show or display the values of this array structure in here? And so we can create the display array function in here, like with the parameter of the ptr, and so as well as the size value in here. Okay. And so in order to create this function, the return value is equal to the void value, and so display array should be equal to the what, or what type of parameter should be included in the display array function. First, the integer star a should be added in here because we need to use the pointer address, and so as well as the int size value should be given to this structure. Okay. And so if we have this kind of information in here, integer I should be defined in here, and for integer I is equal to the 0, but not on this time, and so e is smaller than size, e plus plus, and then the a value can be showed by using these things like this one, a I. Okay. And so at the end of this code we should give the new line at this position. Okay. And so if I run this program, and so the values of these things, 1a blah 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 blah. Okay. And so if I run this program, 1 blah blah blah. Okay. These are different values of these things. And so if we are using the ptr value in here, and so this is called the 1 integer star ptr2 can also be given at this position, and so we can also use the ptr2 value generate random number in here, and so ptr1 should be added in here, and so we can also display the another array is used in this structure. Okay. And so if I run this program, and then there are two variables with the same page of these things, but we can create, or we want to create a different array structure with the different values. Okay. And so what about this? This value should be initialized in what? In this notation. Okay. And so if I run this program, and then the generate structure is equal to also these values. Okay, this is not is used in this notation because this array structure returns the static values of these things, and so we cannot use in the general to notation, and so generate random number is always returns to what? The static int a value in here, or the same address notation to these points. And so the arrays cannot be different values, so cannot have the different values. And so this is the first example session in here, and so we need to redefine the whole codes in order to create a different array structure in here. Okay. And so the example 2 is related to this structural parameters. And then what? Firstly, generate random number should be initialized with what? Integer star a value and the size value in here. Like this one. Okay, and so this is changed with the size value. And so generate random number should be parameter as like the ptr1 10 value, ptr2 10 value. And so what about in this notation? And so if I run this program, there's an error in here because using uninitialized memory ptr1 and 2 in here. Okay, and so we should initialize these values or to what? Or we can set these values, integer a 11 10 zeros and integer b 10 0. Okay, and so ptr1 as an address of the a, ptr2 as an address of b. Okay, and so if I run this code, and so we have two different characteristics or the values on these two array, ptr1 and ptr2, but exactly ptr1 is directed or the pointed to what? A or address of a, and ptr2 points the address of the b value in here. And so this is our first two example session in here. In the next example, we should try the normalized values of this random generation by using what? By using the sum general notation in here. Okay, and so how can we create a generate random number to integer min value or integer max value? Or how can we restrict the randomized values with or by using the minimum and the maximum values of these things? For example, this is the minimum value of these things, 100 and 1000, and so this value is equal to the -5 and 20. Okay, and so how can we add this notation? In order to add this notation, we should add the minimum value in here, and so we should utilize the percentage or the remainder operators in here with the notation of max min value in here. Okay, and so if I run this program and then the 100 to 1000 value is given at this position, 300 650 blah blah blah, and so 9 15 11 7 blah blah blah. Okay, and so this is only related to what? The 100 values, and so this can be increased with this notation, or we can use some different operators in here in order to simulate these things, like this one. The defined value can be given by the size 1 with the notation of 100. Defined value size 2 can be given by the 10 values in here. And so this size should be replaced in these things, this size should be replaced in these things, and so size 1 is assigned to these things, size 2 is assigned to these things. Okay, and so if I run this program and then the 100 values is added in here. Okay, and so but there is only given to display array is equal to the 10 value. I'm sorry, size 2 also given in here, and so there are 100 random value with a range of the what? With the range of the 100 to 1000, and so in the second place the size 2 is equal to what? The 10, and so 10 random number is included in here. Okay, and so this can be equalized to 1000th value in here, and so if I run this program, and so we have the 100 values with the range of the 100 to 1000, and so there are 1000 values or the variables with the type of the integer value with the range of the what? to minus 5 to 20. Okay, this is our general notation on the creation of these things. And so this can be smaller, like this one, 5 and 8, and so this can be calculated by using these things. Okay, or 3 or 7 value is added in here, like this one. Okay, and so how can we calculate the values of, or the summation value of this array body? By using the pointer structure in here. The summation operation is run, and so firstly we should add the new line in here in both two conditions. And so we need to create the sum array function in here with the what, the pointer usage ptr1 and size 1. Okay, and so the return value of this sum array should be equalized to what, the integer sum a is equal to the 0, integer sum b is equal to the 0. Okay, and so this is equal to the sum a value. Okay, and so how can we create the sum array function in here? Or sum b is equal to the sum array with the usage of the pointer 2, and so with the size of the size 2. Okay, these are the main notation to create the sum array function. And so after that we can give this printf function here, sum of a array is equal to the what, percentage d, and so sum a, and so printf sum of b array is equal to the percentage d new line sum b. Okay, and so we need to create the sum array function in here in order to provide the more corrective term into the what, in the summation operation. And so integer value should be returned in here, sum array function body with the parameter of integer a, integer size. Okay, and so firstly we should define the I for the loop value, and so I is equal to 0, I smaller than size, I plus plus, and then what? We need to create the integer sum constants in here with the initialization value of the 0, and so sum cons equal to what? Sum cons plus what? A I in here. And so after that we should return the sum cons value to the what? To the results. Okay, and so if I run this program, and then this summation of these three things is equal to what? 1774. And so in the second place the B matrices of the array is equal to what? 82. Okay, and so in the similar notation of this characteristic, size 1 and size 2 is equal to the 2 in order to correct the last position of these things. 10, I'm sorry, 10, 0 to 10, 0 to 10. And so if I run this program, 8 plus 7, 15, 6 plus 9, 15. Okay, and so if I run this program, and so 0 plus 2 is equal to 2, 3 plus 3 is equal to the 6, and so our algorithm is correct. Okay, and so 220, and so if I run this program again, and then the 954 is the summation of these things, 98 summation of this array structure. And so how can we calculate the mean values of these functions. Mean operation is started in here, and so mean array value with the pointer usage of the ptr1 size 1 and so mean b is equal to the mean array ptr2 size 2. Okay, and so as always we should create the printf function, but in here the mean value of a array should be given by %d mean a printf mean value of b array should be initialized with the %d mean b. Okay, and so we should also create this variable mean a is equal to 0 int mean b is equal to the 0. Okay, and so how can we use this notation? Integer mean array with the parameter of integer star or address point of these things int size, and then what? Firstly, we can derive the integer sum cons in here with the return value of the what, or we can call the sum array function in here. Okay, like this one, a and size. And so how can we return the mean array value in here? Firstly, you should remember that this can have the float point in here, and so this should be equalized to double value in here, and so this d value should be replaced with the lf function in here, and so also the mean array or return value of the mean array should be set as a double value in here. Okay, and so return value is equal to the what? Double cast sum cons value divided by the size value in here. Okay, and so if I run this program, and so the mean value of the a array is equal to the what? 3.995, and the other thing is that b array 3.35. In order to more corrective or the more reliable solution, size 1 and size 2 is assigned to 2 value in here, and so if I run again this program and show the 2 6 in here, there are 2 elements in the a array, and so 2 divided by 2 gives 1. The sum of b array is equal to the 6, and so 6 divided by 2 gives us the 3 value on this notation. Okay, you can check this variable by using this notation. If I run this code and so the mean value of array b is equal to the 3.94, and as well as the a or mean value of array is equal to the what? The 5 values. Okay, and so this is the general notation how to we use the pointer structure on this array structure. And then what? If we have this kind of pointer structure array, we can use this notation on to what? On to for loop or the while loop in the next session, because you can observe these things, or you may have this kind of example sessions on the advanced notation. The second topic is directly related to the pointers advanced usage in C programming language. Okay, and so this session is directly related to the advanced topics on the C programming language, especially in what? The usage of the pointers. Okay, and so firstly we can create an example or session in here like this one. Suppose that we have the 2 variables, integer a 12, integer b is equal to the 100, and so we have the swap function in here a and b, and so the B value is transferred to the A and A value is transferred to the B. And so firstly A and B value is written by to what percentage D, and so A and B can be written at this time, and so as well as in this position. And so if we create the swap function in here like this one, integer x, integer y in here, and so firstly we need to store the temporary variable to what, to x, and so x equal to assigned to y, y is equal to assigned to x in here. Okay. And so y value is assigned to x and y x, and so y is replaced with the x, but what x? This temp x. Okay. And so if I run this program, and then A and B cannot change in this position, and so what does it mean? And so as I recall and you recall after the previous lessons, we should only use the pointers on the swap notation, and so we should use the pointers to swap these address points, and so address A and address B should be given to this swap function, and so int temp can be assigned to what, to these terms, and so we should take the inside operator in here, and so inside value should be assigned these things, and so inside value should be assigned to temp, and so the temp can be recovered or reprotected by using these terms. Okay. And so if I run this program, and then the 112 is translate or convert into the another one, and so A kept the 100, B kept to what, to 12 value on this position. Okay. And so how can we use the swap function into the array structure? For example, like this one. Example 4 is related to the swap function, and so example 5 is related to what, the swap operator on the array structure. Okay. And so if I create the integer A array in here like this one, 0, and integer B is like to what, the 0 values in here. Okay. This is the initialize value of this notation. And so in order to initialize the A and B value in here, firstly we should use the srun function in here with the unsigned cast operators in here like this one. Time null value is the seed value of these things, and so we need to add the include stdlib library, standard library, and so as well as we should include the time.h. Okay. And so the initialization process can be given by to what, the for integer I is equal 0, I 10, I plus plus, and so a I is equal to the rand function in here, and so we can define the 5 plus percentage value with the specific range of these things. Okay, 5 or 5 or 10 minus 5 in here. Okay, and so bi is initialized with the what, the 8 or none 100 value plus random value in here, percentage what 200 minus 100, and so A is within the range of the what, the 5 to 10, B is 100 to 200s. Okay, and so in order to write to these two codes, and so I 10 I plus plus can be given by to what, printf %d, and so AI should be written at this position. Okay, and so as well as this notation, we should add the printf in here, a new line, and so this function body should be added in here, but with the basic difference is that B matrices. Okay, and so if I run this program, and then these values is represented by the A, these values is represented by the B. Okay, and so how can we swap the whole the operators by using the swap function, as I wrote in the previous examples? And so we can use the void function, swap function in here, int address operator or the inside operator x, int star y in here, and so integer temp value is equal to the what, star x, and so star x is equal to the star y, and star y is equal to the temp. Okay, and so how can we replace the whole the variable in this notation? And so swap operation on array structure. We need to add the for loops in here with the initialization value of the 0, e smaller than 10, e plus plus. Okay, and so the swap should be called with the address values of this notation, and so AI and BI should be given to this function, but this is only the value of this array function, and so we should give to what, the address notation in here. Okay, and so after that we should call these functions like this one. Okay, and so firstly printf swap operation is started, should be given at this position, and so after that we should give to what, an a and I value in here. Okay, and so if I run this program, and so this is the elements of the a, this is elements of the what, the b value, but in the second operation first array is given by the a, but the a is equal to b's values. This is given by to what, the swap operation of these things. Okay, and so this is the first example to advanced session on the what, on the pointer examples. And so if I copy off these things like this one, and so we can move to the sixth example in here. And so what about the other usage of to what, or to this notation? The first thing I can give the another points on the what, on the pointer usage. The every pointer integer I is equal 0, I smaller than these things, and so every pointer or the array structure is represented by to what, to these things. One, for example, these things, percentage a percentage d is equal to the percentage d a, or b percentage d is equal to percentage d new line in here. First we should add the I and bi in here. Okay, if I run this program, and so a value is given by these things, b value is given by these things. Okay, but we have another usage to reach the values of the values of the array structure in here, like this one. And so if the a is the pointer, and in the array structure a is the pointer or the int star value, in the type of the a is given by the int star, and so pointers has the arithmetic values. A plus I can be given by using these things, or in order to show that we can use this same notation in here, like this one. Printf, these terms is analyzed or is interpreted by the compilers as the what? As the this one, star a plus I, star a plus I. Okay, this phrase is identical with the what? With these things, and so pointers has the specific arithmetic operators to apply it on what? On the conditions of these codes. And so if I run this program, and then what? We have the same results with the what? With this notation of these parameters. Okay, and so if I run again this program, and then what? Okay, this b value should be added in here, and so these two terms is interpreted as the element of this notation. And so we can note that the pointers are increment or decrement in the notation of what? Of itself. Okay, and so if I use this notation, and then I can assign anything in here, because this parenthesis or the top parenthesis is equal to the what? A plus I. The pointers can be added to another variable or the integer variable, and so if I take the inside value of these things, and so the same result is obtained by using this phenomena instead of using these things. Okay, and so this is the first example session in here, and so the pointers can be increased or decreased, the general results of these things. Okay, and so this is the general notation of these points, and so int star ptr can be defined by these things and a, and so if the ptr plus plus is not equal to the null character, which is the proper null characters in here, like this one, and so if I use this notation, ptr can be added like this one. Okay, and so if I run this notation at this position, and so we can write, or we can use the pointers to create a loop values in here. Okay, and so what? This I value is not a set value, and so we should define this a as the increment values of these things, and so as well as we should add the ptr value in here. Okay, and so if I run this program, and then the address points is not run, and so what? Okay, if I run this program, and so the garbage values is written on display. Okay, and so what? We can use the pointers to reach to what? To obtain the variable of these things, but with the same different notation. If I run these codes, and so we can reach these terms in as well as in here. Okay, we should define to what? The size of these things, and so a plus 10 can be used in this notation. And so if I run this program, and what? This is our main process. This advanced, I know, but you may use this phrase in the C or C++ programming language. Okay? And so if I create the loop variable like this one, and so loop var should be added to these points like this one, plus plus, and so the loop var is added to this notation like this one. So if I run this code, and so 0 1 2 3 4 5 6 7 is written by using the pointer arithmetics like this one. And so a is a pointer or the address of the array structure. But if I add the 10 variable, and so this for loop is current in our approach. Okay? And so the pointers can be used in the loop variable because in the same story is included in the array structure. Okay? Array structure is a masking mechanism, but if we are remove the mask mechanism, the loop is equal to this term. The PTR can be initialized at any address variable in here, and PTR can be checked by the another address point, and so the pointers can be added to any integer values or decreased or removed, and so the PTR can be increased with by 1 byte. Okay, this is the advanced topics, but you should know that. Okay, and so loop var variable should also be equalized at this term is 0. And so what about the while loop usage in here? Firstly, we should add the printf value in here like this one. A %d is equal to the what? %d new line character, and so the loop var is also used in here, and inside or star ptr is also used in here. Okay, printf % new line, and so if we are using these terms, and then we should define also ptr loop variable in here, in star ptr loop variable in here. And so ptr loop at the beginning of the while should be equalized to what? The a value. A is the address of the integer array, and so ptr loop is in the type of the int star, and so ptr loops can store the a address values. Okay, and so what? The ptr loop value is similar than what? Ptr loop value plus 10 the loop var should be increased in this notation, but we should now use the ptr loop value in here. Okay, but if I run this code, and so the 777 is used in here, what's wrong with this code? The wrong is that the ptr loop plus plus should be added in this code. But if I run this code, and then this is an infinite loop on display, because if I can increase the ptr loop in here as well as this term is increased, and so this right hand side is always greater than the ptr loop. Okay, and so there are another variable in here like this one, ptr and is equal to these terms, and so the ptr and should be equalized to ptr loop value, and so as well as the ptr end should be changed with this. And so if I run this code, and voila, 0 to 9 value is obtained with the same, with the previous one. Okay, these topics are the advanced tool, and so you can check my YouTube channel to analyze these codes. But especially in the C++ programming, or in the C programming, you should see, or you will see these notation or these idioms in order to optimize the code structure in the C programming language. Okay, these are the last final session of our lesson. I hope you learn about everything that I said in the C pointer structures, and so we'll see you guys in the next semester.